Alright, the camera stopped after the last video, so I'm going to pick up where we were and then get back to the class lecture. But we're talking about, when the camera stopped, that this inequality, what we're asking about, or what we're thinking about graphically, is that when is the red 2x plus 3, and I guess over here it's orange, but when is that graph less than x minus 2? And we're really interested in asking the question, for what x values are the red or orange y values below or less than the blue y values? So we start to see over here graphically. Now if I just pick a point like x being -8, we see that the red ones or the orange ones are less than the blue ones. Okay, so a y value of -13 is less than a y value of -10. Okay, so hopefully you recognize and you can argue that in all of that picture there, you would agree that the orange ones are below the blue ones. Okay, so then we have to identify what range of values that is, what x values that exists for, and they're the x values from -infinity up to -5, because -5 is where they become equal. Okay, so if I know where they're equal, I should know where they're unequal. Okay, they're unequal to the left of -5 and unequal to the right of -5, but then we just have to determine how are they unequal, which one's greater, which one's less than. So everything we do in this course, when we talk about some type of equation, we eventually talk about an inequality as well, and that's the concept that we're thinking about. Okay, now pick up with what we're doing specifically in class is dealing with absolute value. So our question is, when is the red absolute value 2x plus 6, when is that below 4? Hopefully you guys can argue that, and we're asking for what x values is this red one below 4, and hopefully you can argue that between -5 to -1, those are the x values where the red one is underneath or below the blue one. All right. So what we're going to do is kind of develop a rule here to help us algebraically figure out what that range of values is. So I'm going to start with an arbitrary ax plus b is less than c. And I'm just going to think about just a general one-dimensional number line first. What this is saying is if we've got a 0 here, okay, this expression should be less than c units away from 0. Ax plus b, when I find x, plug it back in here, that x value is going to force ax plus b to be less than c from 0. So less than c, I'm looking for x values that plugging in there will give me something. Ax plus b will be somewhere inside that interval. But we also know that anything over here can also be less than c units from 0. So we're looking at basically that line segment. So the way we find that is we say, well, our expression has to be between -c and +c. So that's why we come up with the idea that if I have absolute value of ax plus b is less than c, we rewrite it as the opposite of c is less than ax plus b is less than c. And we just go through and we solve that. So for our particular problem here, we would rewrite this as -4, take the opposite of that, a less than sign, now our 2x plus 6, and then +4. We're going to go through and solve that. We talked about in class that if you just had that, you would subtract 6 both or first, and if you had just that, you would subtract 6 to solve for x first. So if we got them both at the same time, let's just solve both the inequalities at the same time. So we'll subtract 6 from all three sides, or three parts. Get -10 less than 2x is less than -2. And then again, for the same reason, if we just had that, we'd divide by 2. And if we just had that, we would divide by 2. So just take care of all at once. Divide everything by 2. And we get -5 is less than x is less than -1. And that would be, remember that's set notation. We're going to write this as interval notation, -5 and -1, and that's what we're developing here. Now my hope is that you realize that we know where they're equal. They were equal at -5 and -1, and that would have been That would have been solving the equation absolute value of 2x plus 6 is equal to 4. We've now solved 2x plus 6 is less than 4, so where can we say that absolute value of 2x plus 6 is greater than 4? Well, the place that we say it's greater than 4, if we know where it's equal to 4, and we know where it's less than 4, we should, so that eliminates all of these. We've already taken care of those things. Now, doesn't it make sense then that this is the regions here, the stuff here in yellow would be the regions where they are greater than 4? Okay. So that's the whole idea. There's three components. There's equality, there's less than, and there's greater than. If you can find two of those, you should by default know the third one. Now, you're not always going to be asked to find all three, so we should have an approach that if I'm just asked to find greater than, I can find that directly. And here's the idea. If I have the absolute value of ax plus b is greater than c on a number line again, if 0 is here, c is there, negative c is there, we're looking for an x value that puts my expression ax plus b bigger than c. Okay? But a value over here would also be more than c units from 0. Okay, so any values over here are also more than c units from 0. So that gets these rules. So ax plus b is greater than c would give me this stuff here. And that's pretty direct, pretty easy, I think, to see. But now to get these things over here, we're going to take ax plus b, and we're going to say they have to be less than negative c. And those are the two components that you need for a greater than inequality. And we write the word or in between. Okay, so let's see how that kind of relates to the picture over here when we go and do this particular problem. If I have 2x plus 6 is greater than 4, I'm going to do that. 2x plus 6 is greater than 4. But then I'm going to write the word or, and I'm going to do 2x plus 6 is now less than negative 4. Subtract 6 from both sides, I get 2x is greater than negative 2, x is greater than negative 1. Or, now solve this one, 2x is less than negative 10, x is less than negative 5. And now, these are in set notation. We put them in interval notation. So x is greater than negative 1. So those are the values that are greater than negative 1. Or x is less than negative 5. So negative infinity up to negative 5 are those values. And now we want to make this a number line. So what we're going to do is we're going to put that first, and we're going to put that second, and we're going to union them. And that means then we've got a number line in chronological order. That's the largest negative number, the next largest negative number, or I guess a negative number closer to 0, yet another negative number closer to 0, and then we start getting our positive number. So this should be left to right in order as you would see them on a number line. And that's exactly what we're seeing over here. We've asked ourselves, where is the red curve above the blue curve? Where is the red one above the blue? When is 2x plus 6 above 4? And we're seeing that at negative 5 in that way. So negative 5, negative 6, negative 7, negative 8. Okay, those values, the red is above blue. And then over here at negative 1 and to the right, we're getting the red one above the blue one again. Okay. So that's how you're going to approach those absolute inequalities.